Hi guys, welcome to the session today. We're going to talk about understanding media flows in Microsoft Teams in different scenarios. My name is Eric the Lab Marsi. We'll get on the name in a little bit, and I am a Microsoft MVP and also systems engineer at Cloud Revolution. We're also going to be talking about deploying Argyle mode in case anybody doesn't. If you're in the know, you'll understand the point of that slide. Just kidding, we're not. Richard's not here, so unfortunately, it's not too funny with that. But so anyhow. So we're going to continue on here. So we're going to go ahead and do a little bit about me. We're going to go over the purpose of today's session, kind of understand why you need to understand the path that media takes in your guys' environment. And then we're also going to look at some different scenarios. We're also going to show you how you can determine media paths just in case, let's say something's not working right and you want to find that out yourself. And we'll do a wrap-up and also do Q&A. Q&A we can save to the end. You guys can also ask out during the middle of the session. You're more than welcome to. So I'm from Barberton, Ohio. I am a recent Microsoft MVP. June 1st this past year, I was awarded that. So very thankful and honored to have received that. Just yesterday, I started at Cloud Revolution as a systems engineer, calling meetings and devices. I'm also a graduate of the University of Akron with a Bachelor's of Computer Information Systems with Cisco Networking. And then I have a few certifications. My most recent one was the Teams Administrator Associate. Some of my hobbies involve reverse engineering, tinkering, security research. I like understanding how things work, kind of from a base fundamental perspective. And so kind of being able to play around with things, understand how they work, is just really fun to me. Building electronics, skiing, four-wheeling, also on that list. If you guys do want to look at further content, I do have my website here, ucit.blog. Later this year, I'll probably be transitioning that away to ericmarsi.com. Some change will be coming later on that. And then my Twitter and my LinkedIn is there as follows. So you're probably wondering, why the name, Eric the Lab Marsi? I probably have a lab environment for that. I've got an entire archive of software, pre-built environments, VMs, you name it. And really the name came from last time at Comms vNext, where I didn't have business class internet at the house, brought an entire 4 laptops running a bunch of VMs, with an entire link and exchange environment on stage, and that was my first time speaking at CommsV. And kind of Mark Vail, resident friend at Commsverse, he kind of came with the name Eric the Lab Marsi in that tweet that you guys see there, so kind of sticking with that and going forward with that. So have a lot of fun with all those type of things. So we're going to go ahead and jump into what the purpose of today's session is. And really, with COVID, with everything happening, we're really in a distributed hybrid workplace today, where we've got users now back in the office, we got people external, and really be able to optimize that experience so that we can decrease latency, we can decrease the chances of jitter occurring, or different things happening with the audio or the media streams in your environment. It will really kind of provide a better and much more responsive experience as compared to something, let's say you have an internet connection, you're running cellular, for some reason, it's going to sound like crap. And so today we're going to go ahead and go over Teams-only user to PSTN scenarios, Teams-only user-to-user scenarios, and then also some hybrid on-prem interop with cloud Teams-only users as well. So the first one we're going to go ahead and look at is Teams-only PSTN scenarios. And the first part is direct routing without media bypass enabled. So in this scenario, you've got a user that's internal to your organization. You've got an SBC, an SBCHA pair, an active-active pair in this scenario. And any call that goes out to the PSTN is going to go out to Microsoft Teams, come back in to your SBC, and then get routed to the PSTN. So this is, one of the things that happens with Teams when you deploy it, that you're going to have scenarios where if you have 50, let's say 500 users going out to Teams, coming back in, you're also now requiring double the bandwidth that you would traditionally need in a standard scenario. So instead of just going out and calling it a day, you're going out and coming back in twice. Now, if you are running a direct routing as a service part of your organization, this is going to always be the case. The difference is that those SBCs are not on-prem. Those are in the DRaaS provider's cloud. So you're not kind of coming back in, so it's going to be okay in that scenario, but when you really have those SBCs on-prem, you're going to add that latency, you're going to add those chances for call quality to go down. It also is the default for non-media bypass scenarios. So if you are running media bypass in your environment, and let's just say it's not able to reach the SBC directly for whatever reason, that's a bad, that means you didn't deploy it right if you're running that scenario. This is what it's going to default back to, and it's going to rely on the services in Teams Cloud to reach your SBC. So with an external user, the only difference is that instead of going out of your network, you're kind of coming back in and going to the PSTN, but that user is already connecting to Teams in the cloud. So that's kind of an okay scenario. You're not going to really run any issues with that. It's just you're not going to have that direct path to your on-premises SBCs. So very similar to the internal versus external users. So what happens as soon as you enable media bypass? So as soon as you enable media bypass, if you have an internal user that's dialing out, what's going to happen is you're going to have a hairpin on your firewall. It's going to kind of go into that firewall and come back into that SBC that's on the DMZ. And that media is flowing as quick as it can directly into that SBC. So with that, you're going to have pretty much however fast your internal network is, so gigabit, 10 gig, direct into that SBC, and you're not going to have any of those issues that are going to come with that. Now, media bypass is only supported with a few clients, so that's your PC and Mac desktop clients, the Android and iOS clients, and Teams native phones. If you're using a web client, there's not a way for the web client to be able to get the network stack from your PC, so media bypass will never be available when you're using Teams on the web. Also, the other thing with media bypass is that the organization has to allow connectivity into that SBC from any IP address. So in a non-media bypass scenario, you're only allowing you can set up to any IP, but you only need to allow the 52.114 address, and there's another 52 address, not remember off the top of my head, that you need to allow into your SBC. In the media bypass world, you need to allow all IPs into that SBC. And as mentioned before, if it's unable to form a relationship for media bypass to work, it will revert to using the transport relays in the cloud. So for an external user, the difference is that instead of kind of doing a type of hairpinning, they're going to bypass that Teams service, and they're going to go right to the SBC for direct media connectivity. So if your users, let's just say a mile down the road, you're not going to want to go out to your local Azure data center and then come back just to get to your SBC for media flows. You're going to want to go directly to that SBC because it's going to be a low latency to get to that device. Any questions so far? Cool. So we're going to go ahead and talk about survivable branch appliances. And I kind of jacked any nodes diagrams because they are very good diagrams. So in the event that you have an SBA deployed in your environment, so whether it's an any node where it's combined in the SBC, or if you have a virtual machine with a ribbon or another audio codes device, the media flow is going to go with how you have it set up. And with SBAs, it also requires that you have media bypass configured so that you can get that direct connection to the SBC. So in this scenario, we've got a Teams user that is right now outside the organization. They have a registration both to the Teams service, and they have registration to the SBA. The thing is, though, when the service is able to reach, the application is able to reach Microsoft Teams, it is never going to try to route to that SBA appliance that is on premises. It is always going to route through Office 365 and do its standard routing and kind of forget that that SBA appliance is there. Now, what happens when things break? So in this case, we've got an external user in the organization that is outside of your network, and it is no longer able to communicate with Office 365. So whether there's a Teams service outage, something happened with internet connectivity, but they're still able to reach that SBA appliance, the signaling for that call is going to go right to that SBA instead of to the Teams service. And then the media path for that is going to go right into the AnyNode SBC. Now I'll get out to your PSTN and go from that scenario. Now with an internal user, if you notice, you've got the Teams client internal, and it has an outage, whether it be like an internet outage at that local organization or going back in. And what happens is that the media flow will go right to that SBC internally, but it's accessing it on the internal interface of that SBC versus just the external one. So there's that. Now, when we get into local media optimization, who here knows local media optimization? Cool, glad to see it. So local media optimization, for those who do not know, is really what you're doing to optimize media flows in your internal network. And this kind of involves keeping media internal to your network with lower latency. And the one thing that's different with local media optimization, we're going to go into a few different scenarios with it, is that instead of having to go into that external interface on your SBC, you're able to go into your internal interface. And that's kind of just in a centralized SBC scenario that we'll talk about here shortly. Also, it's kind of supported in two different scenarios, and those two scenarios we're going to talk about are the centralized SBCs in the organization, and then also if you have proxy SBCs. So the proxy SBCs are kind of SBCs that are in a branch location that aren't directly connected to the internet, that may be able to be reached on your internal ELAN, MPLS, SD-WAN solution, but not exposed directly to the internet. And maybe you have like a PRI at that location you want to access via Teams. Also with local media optimization, it does require that media bypass is configured properly, and it does not support the SBA functionality today. I'm not sure if that's going to come in the future, but if you're looking to use SBA with local media optimization, if you have a Teams service outage, you're going to lose connectivity to those SBCs. And it comes down to really how local media optimization works, is because you're defining all the IPs of your internal subnet, your external trusted IPs, and it has to look up to the Teams service to find out, hey, where am I in this network? How do I reach this SBC? So when it can't reach that Teams service, you're going to be unable to reach that internal SBC. And there's only good. We'll kind of proxy throwing this out. Oh. I did not play sports in school, so.
All right, so there's some typo there. May I correct there?
Yeah, go ahead.
Okay, so supported in the two scenarios, central SBC is, I think, is proxy SBC.
Yeah.
And then the bottom there, proxy SBC should be, I think, is downstream SBC.
Downstream, yep.
Yeah.
I was
Just
wondering that. I was like, oh crap.
Oh, yeah.
Awesome. And so it is also, as mentioned, is only supported on certain clients only. So that's going to be your Windows desktop clients and your Mac desktop clients today. Not sure if future clients will be supported, but that is what is supported today with LMO. Awesome. So we're going to go ahead and look at LMO with a centralized SBC and a kind of a centralized trunk. So we've got a user that is in Germany in this scenario. And we want to go ahead and get connectivity to the PSTN. So the user in Germany is going to go reach out to Office 365, and it's going to say, hey, I need to make a phone call. Here's where I need to go. Office 365 is going to say, hey, we need to route you to this SBC, which is the centralsbc.contoso.com. And with that, the signaling is going to go between back into from Microsoft's cloud into the SBC. The SBC is going to say, hey, here's where you can connect to me at. And as soon as that happens, the SBC will create a call that will create media directly from that user to the internal interface of that SBC, and then route that directly into the PSTN. So in that scenario, we're not running anything out to our firewalls. We're not running anything out to Microsoft. It is going right to the SBC and then out to the PSTN. Okay? Now, when you are an external user in that scenario, the media is going directly to the SBC, again. So it's very similar to direct routing with media bypass in this scenario. So there's really not much difference in that essence. But it is sending that media directly to your SBC, so you're not going across any type of internet backbone. You're not increasing latency. You're going as quick as you can to that SBC's edge. Now, if we have internal user that has downstream SBC, and that's a downstream SBC, so that's one that's not exposed to the internet. What's going to happen? So the Teams user is going to say, hey, I need to make a call to this destination. Microsoft is going to come back to the SBC and say, hey, we need to create a call. This is the downstream SBC that we need to reach. And what's going to happen is it's making this decision based on your network address. So if it determines that you are an internal user at a specific site, it's going to say, hey, I need a route to this SBC. So in this case, we've got SIP signaling that's going to go down to our downstream SBC. It's going to say, hey, we need to create a call. The internal user is here. We need to go out to the PSTN. And in that case, the user is connecting to an SBC that is local to them, not exposed to the internet, but exposed local to them, and then routing directly out to the PSTN. So in this case, if you think about that, Vietnam and Singapore, those are quite different geographical areas. So if you wanted to go out to Singapore and come back in, you're going to be adding a lot of latency, and it's going to result in a very poor audio call for you. So when we look at an external user with a downstream SBC, how does it get to that SBC? So it's going to be very similar to direct routing with media bypass, where it's going right to that proxy SBC that's on the edge and connected to Office 365. But then the signaling and media is going to flow between those SBCs just to get to that PSTN connectivity. And then you can see that over there in the bottom left, so that media flow is going right through that SBC and going out to the PSTN. Okay. So now, if we've got an internal user that is trying to get out to an SBC at another site, how is that going to flow? So that proxy SBC that is on your edge, that is going to kind of act as an intermediary if it can't access the other downstream SBC. So in this case, you have Vietnam, but that user cannot directly access that SBC across your network. And how is it going to get there? It's going to go out to a point that it can get to that network. So let's just say your Indonesia network in this scenario can't reach Vietnam. It's going to go to Singapore's SBC on the internal side and say, hey, I need to reach it because you can reach it. I can't, but you can. And then it's going to go relay the media through that out to Vietnam and then connect that out to your PSTN, whether it be SIP or PRI, or however you're connecting into that environment. Any questions so far? Okay. So in this scenario, we're going to look at non-PSTN scenarios. So what happens when you're using Teams and just peer-to-peer calls, conferencing, et cetera. So in this scenario, we've got two users that are both on the internal network, and they want to call each other. So when you make that call, you're going to have the red line there. That's going to be their signaling. That's going to go out to the internet, go to Teams, and say, hey, I need to call user 2. And at that point, it's going to come back and say, hey, user 2, user 1 wants to call you. The two users are going to communicate with each other, and they're going to say, hey, here's my IP. Can you reach me? At that point, if both users can reach each other via their internal IP on the corporate network, the media path is going to go right from client to client and supported clients. So, pretty much at that point, you're relying, again, on your internal network's bandwidth, so you're not going across the internet just to get that communication. So pretty much if I say something now on that one PC and I go to another one, it's going to be very instantaneous on how that flows. Now, in the event that direct media cannot be negotiated, so let's just say you've got two separate subnets the users are on the internal network on, and for some reason there's something that's going to block those two users' connectivity to each other. It's going to follow the same path that you just saw for signaling. So it's going to go out to Teams, it's going to relay that through Teams, and then the connection will go back down to the other Teams user as long as it can reach it. So kind of just, if you're in a scenario where you've got a really locked down corporate network, it's going to be on to Teams. Now, when you have an external user, the difference is kind of there a little bit, where you're not relaying through Teams' services, but you're going directly to that user on the external side of on the internet. And that's all if their firewall on that end is allowing you to be able to get that the direct communication in. There's a chance that they may not be able to. Some firewalls, some different providers will prevent that from happening. But again, in that case, it's going to follow the same path that signaling is using if it can't do direct media between those two clients. Now, when you have two external Teams users, again, it's going to be like that, where you're going to try to establish direct media between those two users. If it cannot get direct routing, direct media between those two users, it's going to, again, relay that through the Teams service in the cloud. So now, what happens when you have more than two users? So as soon as you add another user to a group chat, a peer-to-peer session, or even create a conference, all signaling and all media streams goes directly into the Teams service. Because what's going to happen is they're going to send all the media together, and then there's a service within Microsoft's cloud that mixes the audio together so that no matter who's joining that session, whether it be 3, 4, 5, however many people are joining that meeting or group call, they're all going to be receiving the exact same audio stream at almost the exact same time. So you're not, each client's not trying to establish its own media leg, and there's all these other issues. We're just going to send everything to Microsoft's cloud. There is no way around that. That's how it's designed. It's honestly a very good design. Now, SMB clients cannot join a Teams meeting. So if you had a scenario where you had a Skype for Business user, then they wanted to join that Teams meeting. If somebody in Teams invited them, they're going to get a join link to join a Teams meeting and use a Teams client. They're not going to be able to use that Skype for Business client. The one exception to that is if you have a Skype for Business 3-pip phone. Those 3-pip phones are going to be able to go ahead and sign directly in to Teams. Well, it's still saying it's Skype for Business Online in the back end, but it's able to do one-touch join into those Teams meetings via a service that's in Microsoft's cloud. So now, those are all the Teams-only scenarios that we're going to cover. What happens as soon as we start having a hybrid organization? We've got Skype for Business server on premises, and we really want to see what happens when we have calling between those users. So in this case, we've got an internal Skype for Business user and an internal Teams user. We've got an SFB Edge, we got our SBCs, and everything is kind of connected together and happy. But what happens as soon as we are on a Skype client or on a Teams client, we want to call somebody else that's on the internal network and is able to be reached. So if I'm a Skype user and I make a call, it's going to go to our front-end pool. Front-end pool is going to say, hey, this user's in the cloud based on the MSRTC SIP deployment locator. That's going to go out to the Edge. The Edge is going to go to Teams. Teams is going to say, hey, I know where this person is. We're going to send signaling, which is that red line, down to the Teams user and say, hey, this Skype user at this IP wants to talk to you. It starts the ringing notification. As soon as that call is answered, direct media will be established between that Skype for Business and that Teams client. So it might be a little bit shocking for people, like, oh, what, Skype's talking to Teams? But the Skype for Business client and Teams clients can talk directly to one another. Now, in the event, again, like Teams, if it is not able to directly communicate with each other, they're going to follow the exact same path for media that you are following for signaling in these scenarios. So the Skype client's going to go to the front-end pool, to the Edge, to Teams. Teams is going to come back. And then at that point, if you're not allowing that direct communication on your internal network, you're adding a lot of additional bandwidth requirements if you have a lot of users that are both on-prem and in the cloud. Now, as soon as you move that Teams user external, it's going to, again, try to negotiate. It's, hey, I'm at this IP, here's the port you can try to reach me on. If it can't reach you on, it's going to go back the signaling path. But the media path that they're going to follow is going to be directly between those two clients as long as it can be negotiated. Any questions? Cool. So now, when you've got an internal Teams user to an external Skype for Business user, signaling gets a little bit complex, where you've got Skype user coming in, going to your front-end pool, they're going back out, they're going to Teams, and the Teams is coming back into your network. Signaling's all over the place. But again, the ultimate goal is to get those clients talking to one another, and we're going to try to get to that point of getting direct media. Again, if you cannot get that media leg directly between those two clients, it's going to go back the same path that you see there in red all over the place trying to get media. So if you think about that, you've got, let's say you can't negotiate direct media between those two clients. You've now got 3 media streams just going in and out, two going in, one going out on your corporate network just to get that call completed and talking to those users. So you really want to make sure that we can have that direct communication, or else you're going to have a very poor audio experience. Now, when you have an external Skype for Business user and an external Teams user, you're going to have the signaling kind of go a similar path that you had when you had an internal and an external one. But again, that direct media is going to be trying to be negotiated between those two clients on the internet or from there. So let's just say your organization, and you may have these diagrams. There's always going to be a different scenario and a potential for something that is unique to your environment that comes up. And you want to determine how you are getting those media paths. So what you're going to use is some similar tools. Wireshark, if you're doing PSTN scenarios, you're going to look at SIP traces, the C equals and the SDP. That'll show you where it's trying to reach the client or the team service. You've got client logs. Snooper, rest in peace. Hopefully we get something for that for Teams soon. And then also, if you're really wanting to get into it, even port mirrors. So like if you have like a 3-pip phone, for example, and you want to see how that media is flowing, 3-pip phone is going to flow directly out to Teams, but you can at least find that out in those different scenarios. So what we're going to do, this is where the fun begins, and pray to the demigods, right? So one of the things I wanted to pull up was first a SIP trace. So this is just a standard audio code SIP trace. And over here in the bottom, we have a 200 SDP going back from the Teams service going to my SBC and going to the PSTN. And in this, we'll see down here that we have a C equals in IP4, and then we have the 52115, which is the Teams service IP address. And what that is saying is that in order to establish direct media, not direct media, but media for this call, you're going to connect to the Teams service of this IP. It's telling the SBC that, and the SBC is going to say, I want to connect here. Now, in a scenario where you've got media bypass or you've got local media optimization, that's going to be a different IP. You're going to start seeing more internal IPs in these scenarios because you're going directly to that client instead of going out to Microsoft Service and coming back on premises. Also, if we go ahead and we pull up our VMs here, sign in real quick. So I've got a user here. We have the Teams client installed on it. And what we're going to do is we're going to initiate an external Skype for Business user to an internal Teams user call. But what I'm going to do first is I'm going to go ahead and open up Wireshark, and we're going to begin capturing on the interface that's on this PC. So we're going to see lots of data going in. There we go. And we're going to go over here, bring up my Skype for Business client that I have. And we're going to bring up that Teams user, and hopefully maybe bring up the Teams user. Where are we at? Let's try to go over here. And we're going to go ahead and start a call to that Teams only user. And mute our mic, so we don't run any scenarios. And we're going to go in and answer that on this user's machine. So we are using a supported client. We're using that Teams application. And so since this is a Skype for Business interop call, we're going to say, hey, you don't have certain features in this call. That's to be expected. Things are fine in that scenario. But what's happening in the background, if you open up Wireshark here, minimize, you'll see that there is a lot of UDP traffic that's going out. It's going to port 50,003 and 24,384. And if you notice, the source and destination are internal IPs. They are not external Microsoft IPs. So right now, these two clients, it's connecting to my laptop because I'm on a VPN. So I'm not going out to the internet and coming back in. I'm just going right across my personal VPN. But that data is going directly across that VPN. It's not even trying to reach Microsoft's cloud. Now, if for some reason I went on my firewall and said, hey, you're not allowed to access anything on the 50,000 port range, or I completely restricted this, the call is going to say, hey, I can't reach you at this IP. It's going to go out to Microsoft. In that scenario, you're going to start seeing 52 addresses where the media is going out to Microsoft and then coming back on-prem. Now, right now, Wireshark's just capturing all network traffic, so you're going to see a lot of things of that matter. And I'm going to go ahead and terminate that call real quick. You guys all missed that sound, right? And what we're going to do is we just filter simply just by UDP. And really, when we start looking at the UDP traffic, you're going to start seeing a lot of things in here that are specific to your environment. But if we start scrolling down, you're going to start seeing, we had some signaling that went out to Microsoft at the 52114 address. But if we keep on going down that packet capture that we just did, we've got the local IP right here, 10.10.2.1 and 172.16.10.2, which is my laptop that's right here. And that is going directly across internal means to reach those two clients. Okay? So that is Wireshark. Any questions? Very basic understanding of Wireshark, not too in-depth there. You'd play around with that thing for quite a long time. So we're going to do a little bit of wrap-up, but I do have some fun in here, so stick around for that. And really, one of the things that I want to talk about is that there are many, many more scenarios. There's practically an infinite amount of scenarios depending on how your network's set up, whether you have, hopefully you haven't the IPs bypassed, but if you're using internal proxies in your network, there's, I'm looking at the wrong screen. Apparently, it's not even presenting. Awesome. There we go. Cool. Sorry. So we got full tunnel VPNs. Hopefully we're letting the 52 addresses go away, but just in case you're using those, ExpressRoute, SD-WAN, proxies, centralized internet connectivity. There's a lot of scenarios that could be unique to your environment. And we really want you to be able to go ahead and look at your environment and understand how you can determine these paths. Also, I want to thank our 2021 sponsors for CommsV. Would not be here. None of this would be possible without you guys. So if you guys are in the audience, thank you guys very much. And then also, please complete your evaluations. If you liked it, if you hated it, if you didn't care about anything I said, please let me know. I always like the feedback, and we'll always take that forward. Community events, we have the National Skype and Teams User Group at teamsug.com. So we have quarterly sessions with that. So do pay attention to that. Now, so this was not originally part of my presentation. Has nothing to do with Teams, so if you guys do want to step out, you can. But this is more or less a bet, and I'm going to point at him. Sean, challenged me. He's like, hey, I built this and played around with this, and I think you guys worked on it on the product group, right? Oh, you're in marketing for it, okay. And we're going to go back in time, and we're going to think that this is LinkConf. And what we're going to do is we've got some Skype on-prem stuff. So with that, we've got a user on that VM that we were on previously that has a Skype client, but if you notice, it's got Link UI on it. And back with the old Skype stuff. This is just playing around. This is just having fun. So take a step back in time. There was a point where they started bringing the Skype for Business UI. They had the Skype servers, but they didn't want to roll that out to their users without having appropriate training first. And so with that, if you rolled out a new client without teaching your end users and saying, hey, here's how you use this new UI, it's very similar, but it's different, users are going to complain, help desk tickets are going to go up. So one of the things that Microsoft did, that Sean was the marketing guy for, I guess, is that they enabled a feature in the client policy that allowed you to say, I want to enable the Skype UI or I want to disable it. So in this case, this user has a client policy assigned that says, hey, we want the Skype UI disabled. And the way you kind of find that out is you have your user in the Skype Admin Center, and they have a assigned policy assigned to them, and it says, hey, here's my client policy. Now there's a chance they're using global. In this case, my account is just using a pure offline custom policy that I built myself. And what we're going to do is we're going to pull up a Skype front-end server here real quick. And what we're going to do is go ahead and do a get-cs client policy, identity, and then global appear global dash offline. Bam. Might help if I had the context there, right? Cool. So we get a lot of things back, but one of the things that we're looking for is an attribute called, we'll just kind of filter by this. I have the commandlet further up or whatever. And that's enable Skype UI. And I'll just run that again so it kind of gets brought down. We see that as set to false. So we're right now saying that that is policy set to false. In this case, we want to go ahead and say, hey, let's set this to true. Because we want to enable Skype UI. We have a group of users that are part of that client policy. Go ahead and hit true. So now that client policy is down. We're going to go over to our client. Now, you could wait for the client policy to update in the client, but what we're going to do is we're just going to force that a little bit. So we're going to sign out of our client. Delete sign info, clear your cache, sign back in, sign back into my user account. If I can type my password right. Give it a second. Client's going to sign in. It's going to start pulling on the client policy. And then hopefully, fingers crossed, it'll pop up and say, hey, you guys have a new UI. You guys are running Skype's business server. It's going to say, hey, we need to sign in. Just in case that doesn't pop down, we can just exit and reopen. Fingers crossed. Nope, still getting the Link UI. Awesome. Oh, there we are. Bam. The organization is wanting to upgrade to Skype for Business. The users were trained. Bam, restart now. Link client will close. As soon as it restarts, it's going to open up. Bam, Skype for Business. You're now signed in, and you're using the new UI. So, a little Easter egg bonus. Take a little step back in time, Get everybody thinking of all the fun that we used to have, even though I was in high school then. But so with that, I'll kind of minimize this here. I kept the screenshot in here just in case I didn't get the policy refresh. Any questions from anybody? Yes, sir. Dave, who has the box? Oh.
All right. I have a question regarding local media optimization.
Okay.
So the Microsoft.com, there's some known issue regarding local media issues. So Microsoft is working on resolve that known issue.
Yeah. So there are four. I think like 4 known issues.
5
4 or 5 on the docs site. I can't remember off the top of my head exactly which ones those are. I think like it involves like call transfer is one of them. the referrers not working correctly with local media optimization. I can't remember what the other couple are.
Right. And then the call escalation.
The call escalation, yep. Yep. So right now, still today, those two features are not working, but hopefully as they evolve the product and they add more features, those do kind of come forward. And did you have a specific question about them, or?
No, that's it. I just want to know it's going to be, fixed.
I have not heard anything through any of the means. I can bring that up to the product group and hopefully.
Yeah, my customer is kind of like afraid of they moving forward local media optimization, but they have some caveats. So.
Yep.
Thank you.
Awesome. Thank you. Anybody else? Awesome, guys. Well, thank you again. Thanks for coming to CommsView Next. I hope you guys have a great rest of your conference. Safe travels home, and thank you guys for being here today. Really appreciate it.